Hey everybody, welcome back again. Mr. Anderson here with another edition of Algebra 2. Today we're going to talk about section 5.8. We're going to talk about the rational zero theorem, and it's kind of similar to the stuff we've been talking about where we're going to find the roots. Okay, so the roots and the zeros. So let's get started. All right, first of all, our objectives. Number one, we want to identify possible rational zeros of a polynomial function. So we're looking for what are the possibilities. There's a kind of a thing that we can go through to find out what are the possibilities. And then we want to find the rational zeros. All right, so let's start with the rational zero theorem. Basically, what we got going here is this is kind of a little pattern that we can use to find all the possibilities. Using P and Q. Okay, so the possibilities are going to be all the P's divided by Q's. So so when they say watch your P's and Q's, you ever heard that? Yeah, that's what they're talking about. I don't know, but it might be actually. But the P's are all of the factors of your number at the end here. So in this case, factors of 40. And Q are all the factors of your leading coefficient 6. And so all the factors of P divided by Q give you the possibilities for your zeros. Remember, these do have to be in descending order. So your leading coefficient and your biggest exponent come first, and it works your way down to just your number here, just a constant. Okay, it'll make a little bit more sense when we do a couple here. Let's take a look. All right, so the possible rational zeros, first of all, let's look at our P's. Okay, what are the P's that we have? Well, it's the factors of 4. All right, so, and it's both positive and negative. So factors of 4 could be what? 1 times 4. Those are factors. What else? 2 times 2. Now we only have to write 2 one time, but both the plus and the minus of 2. And then Q would be the factors of 3, so 1 times 3, both plus and minus. So we can see our P's and our Q's. And then to actually find the possible rational zeros, it's going to be P divided by Q. So we're going to take each one of these divided by 1 first of all. I always start with that because that's the easiest. So you're always going to have plus or minus 1, plus or minus 2, plus or minus 4. So 1 over 1, 2 over 1, 4 over 1. But then you've also got the dividing by 3 here, so you also have a possibility of plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. So in this case, those are our possible rational zeros. And if you, in a second, we will actually find the rational zeros. You'll see that it'll be one of, the zeros will be within this group if we were doing this problem here. Okay? But for right now, in this kind of problem, we're just finding what are the possibilities. That's what they are. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/3, 2/3, and 4/3. Okay, those are the possibilities. Back in the old days, this was really, really great because without calculators, and actually the book still even shows this, find your zeros by plugging it in and doing synthetic substitution, and you keep plugging in numbers until you find one that works. Remember, if you end up with 0 as your remainder, that would be a 0, what you divided by. And so so this could really limit what you'd have to try. If you could limit, all the possibilities that you could try, you could limit it to these. That's a lot less that you have to try. But that's still kind of a lot. And now that we got these newfangled computers, it's a lot easier. By the way, notice I've got a different calculator here today. My old one was kind of messing up, so I downloaded a new one. So here's a new one. I can't resize it though, unfortunately, but it works at least, so that's nice. All right, well, let's look at one more of this, and then we'll actually find some of our actual zeros. All right, so here's one more. We want to find the possible rational zeros. So the p, we have plus or minus 1, 1 times 6, but then we also have 2 times 3. So those are the possible p's, and the q's, we have just factors of 2, so all we've got there is just 1 and 2. So we've got all the combinations of p over q, which would be plus or minus 1, 1 over 1, plus or minus 2, which is 2 over 1, plus or minus 3, which is 3 over 1, and 6 over 1. So we got all those, but then we also have 1 over 2, which is 1/2. Then we've got 6 over 2, which is 3. Oh, we've already got that one. I don't have to write it again. So, good. 2 over 2, which is 1. I already got that. Don't have to write it again. And then 3 over 2, so we also have plus or minus 3 over 2. So these are our possible rational zeros for this function. Okay? So far okay? Not too bad. Just watch your P's and Q's. All right, now what we're going to do is we're going to find all the zeros, all the rational zeros. Okay, remember the rational zeros we'll be able to see on the calculator. The imaginary zeros we will not be able to see. So keep that in mind. We're just going to find the ones that we can see here. So again, as I said before, if you find all the possibilities here, then you could use those possibilities to do synthetic substitution to find out which ones work. But these days, with these fancy calculators we have, we're going to use the calculator. And that'll help us quite a bit. It could still be a little helpful knowing the possibilities, and I'll show you what I mean here. So first of all, let's find all our possibilities here first, and then we'll look at it on the calculator. So my p's here for 12 are what? 1 and 12, 2 and 6, 3 and 4. And then for the q's, we've got just 2, so it's just 1 and 2. So my possibilities for p over q are 1, 2, 3, 4, 6, and 12. But then also 1/2. We got 1 over 2. 12 over 2 is 6. Already got it. 2 over 2 is 1. Already got it. 6 over 2 is 3. Already got it. 3 over 2, don't have that. So possible plus or minus 3 over 2. And 4 over 2 is 2. Already got it. All right, so here's my possibilities, just like we did before. Let's actually find what ones really are rational zeros now. And I'm going to go to my calculator, turn it on, go to the y equals button here. Can you see that? Go to the y equals button, and let's just type in our function here. So 2x raised to the 4th power plus 11x to the 3rd plus 26x squared plus 29x plus 12. That would be plus 12. All right, so there I've typed it in. Let's just graph it and take a look at it. So apparently I've already zoomed in on this here, so you can see this is zoomed in a little bit. If you had it out at the normal viewing window there, you notice it's a little hard to see exactly what's going on there. I think that's why I'd zoomed in previous. So zoom it back in, And we notice that it crosses in two places. That means there are 2 zeros. Okay, so we know we got to look for 2 zeros that we can find. Well, remember, biggest exponent is 4. That means there are 4 total zeros, and if we can see 2 of them, what does that mean? The other 2 are imaginary. Good news is, when it says find the rational zeros, I don't have to find the imaginary ones. I'm just going to find the ones I can see. So that's a little nice. All right, let's look at the table. Second function, table. Remember, look down your y column where there's a 0. The number that goes with it here, -1, that is one of your zeros. Okay, so here's what we got right now. We know that -1 is one of our zeros because we looked and saw it over here. Now, I don't see any other zeros. Interestingly enough here, with this one, I don't even see it changing from negative to positive to find the other 0. So let's go back and look at the graph. And we notice this is 0, here's -1, -2. So this other one crosses between -1 and -2. So here's where this can come in a little handy is, I can look at my possibilities here and I say, well, what are the possible numbers that are between -1 and -2? Well, 1, 2, 3, 4, 6, 12. None of those are between 1 and 2. By the way, notice we had -1. That was one of our possibilities, -1 right here. So plus or minus 1/2. Well, positive 1/2 would be here, negative 1/2 would be here. So it's not that. But plus or minus 3/2, that would be, 1.5 or -1.5. So you know what? Since these are the only possibilities, this must be -3/2 or -1.5. So we could say -3/2 is my other 0. So -1 and -3/2. Because I knew that the only possibility for a 0 between -1 and -2 was -1.5. Okay. By the way, the other thing that we've talked about before too, I could check this. How could I check it? Second function, calculate, find the 0, number 2. Left bound, I don't know where we are here. There's our little blinky dot. So enter, move it to the right of the 0. Oops, I hope I got it far enough there. And enter. Look what it said, 0, -1.5. That's -3/2. So there's another way we could find it just with the calculator. And you notice that does confirm -1.5 was indeed a 0. Okay, see how kind of a lot of this stuff is coming together here? All right, let's look at this one. Now we're going to find all of the zeros. And this is basically kind of what we had done before. So we're going to, if there are imaginary zeros, we're going to find those as well. And basically we've done this in the last section. So it's kind of more of a review than anything. So let's go ahead. I'm going to zoom this back to the normal thing here. Let's go ahead and first of all type this into our calculator. X raised to the 4th power plus x raised to the 3rd power minus 19x squared plus 11x plus 30. Okay, so first thing, let's take a look at our table and see what we can find. Well, now interestingly enough here, since we have these newfangled calculators, look what we got here. We can probably save ourselves a lot of time. I'm not even sure where the other one is here. I think there's another one that shows up on here. But there it is. Remember, our zeros are where y is 0. It's the x value that goes with that, right? So you notice, how many zeros do we have? 4, right? And if you look here, here's a 0. Here's 1. And if you scroll down a little bit, here's 2 more. So all 4 of them are right there for us. So very, very easy on this one, actually. So our zeros, if we use our calculator here anyway, our zeros are, let me start back here, we've got a 0 at -5 because of this one right here. Here we've got one at -1, and then we've got another one at 2 and 3. So 2 and 3. So that was kind of easy using the calculator. All we had to do was look and find that. And if you hit the graph here, here's the graph. And if you look closely, here's -5, -1, 2, and 3. So you can see they're all there. They won't always be that easy. Usually, you know, there's going to be at least one good 0 with that, you know, that we can find here, and we'll do synthetic to kind of get that depressed polynomial and work our way down. We might have to factor. We might have to use the quadratic formula. A number of things that we might have to do there. So anyway, let's look at one more. All right, so on this one, move that over a little bit. Let's go ahead and type this one. Start by typing this one into our calculator here. So I've got 5x to the 4th minus 8x to the 3rd plus 41x squared minus 72x minus 36. Oop. 36. All right, that looks okay. So let's just graph it first. We'll take a look. It looks like we got two places that it's crossing. I'm going to zoom in and see if we can't get a better look. And it does look like it crosses in two places there. And interestingly enough, let's see, where was that one that I did? Wonder if I typed that in correctly. I don't know if I typed that in correctly, to be honest with you. 5x raised to the 4th minus 8x to the 3rd plus, oh, that's why 41. Look at that. It's not working out the way it's supposed to. 41x squared minus 72x. There we go. I knew something didn't look right there. All right, there we go. That's what our graph would look like. You can see it crosses in two places. I'm going to zoom back out. Number 6Z standard. So that means it crosses in two places. That means we also will have two imaginary zeros that we're going to have to find here. All right, well, let's just start with the table. And you notice we got one good spot. Like I was telling you, usually you'll be able to find one good one here. So we know that we have 1 0 that's at 2. And so we're going to do synthetic here to take that factor out. So here's what we have. 5, -8, 41, -72, -36. So 5, 10, add those two, 4, 45, 90, what's that going to be, 18, 36, and 0. Good. Okay, so that worked out right. So our depressed polynomial is 5x to the 3rd plus 2x squared plus 45x plus 18. Okay, so remember we do have 1 0. I'll write it up here. We already have a 0 of 2 because that's what we found right here. We have one of our zeros of 2. So I really need to find one more rational one, and then there's going to be a couple of imaginary ones too. All right, so from here, what are my options? You know, one of the things that I could have done, let me turn that back on there. One of the things that I could have done, actually, let's look at the graph here. If you zoomed in, one of the things that I could have done is I could have noticed that the other zeros between 0 and -1. So I could have found that, you know, by doing all the possible zeros here, like we just did with the P's and the Q's, and then divided that out to see what was left. But in this case, there are 4 terms. What should happen here, I believe, is we should be able to factor this. Remember, we can factor these too if possible. And since there are 4 terms, we're going to try to do grouping. Okay, what do these two have in common? They both have an x squared. If I take out an x squared, what's left is 5x plus 2. And here I could take out a 9, and what's left is 5x plus 2. Yay, look at that. So the parentheses are the same, so that means this will factor down to x squared plus 9, 5x plus 2. Again, remember this equals 0 here. This is the way we're doing this. And so we just set each parentheses equal to 0. So if x squared plus 9 equals 0, that means we go minus 9. X squared equals a -9. Take the square root. So x equals plus or minus. Remember, square root of a -1 is I, and square root of 9 is 3, so this would be plus or minus 3i. So, so here we got plus or minus 3i. So there's 1, 2, 3. There's 3 roots. I got 1 more left, and that's going to come from this parentheses down here. And 5x plus 2 equals 0, so minus 2. 5x equals a -2 divided by 5. And so we got also -2/5. Which, by the way, if you would, I'm not going to do it here, but if you would have found all the possible zeros, you know, with the P's and the Q's, you would have found 2 would have been a possibility, and you would have also found -2/5 was one of your possibilities as well. But we didn't have to resort to that here. We were able to factor it. So I know it's, you know, there's not one set way to do these things, but just, you know, hopefully we've started to do enough of these where you're starting to notice that you can plug stuff into your calculator here and at least get you started. You might be able to factor with what's left once you do the synthetic. You also have the possibility of finding all of the P's and the Q's and finding your possibilities and then just kind of figuring it out from what you've graphed on your calculator. You know, you could figure out what the possibilities are, and if there's only one possibility in the area that you're looking for, you know, you kind of know what it is. So, you know, there are a lot of different possibilities. I know that makes it a little hard of different ways to do that, but just kind of keep all those ways in mind, and of course we'll just keep working through this and hopefully get it all figured out pretty soon. All right, well, that's going to do it for this edition. This is the last one in this chapter, so we'll look forward to seeing you again in the next chapter. And until next time, see you later.